So for part B, this is the same directions as part A. We're going to have to graph. We're going to have to describe the transformations. Okay, so we're using the parent function, y equals x squared, as a guide. So the first thing we're going to do is we want to find the vertex. Now this is not in its simplest form. So if it's not in the simplest form, we are going to simplify. We just have to remember our exponent rules. So if you have 3x squared, what happens is that power of 2 gets applied to the 3 and the x. And then we know 3 squared is what? 9. So this is 9x squared. Okay, so this is the simplest form of g of x, and we can use that to help us with finding the vertex. So remember yesterday we talked about how your vertex, you can find the x coordinate by using the opposite of b over 2 times a. Now the b value is always in front of x, but there's no x there. So that means your b value is 0, your a value is 9. That's why you want to simplify, is so you can see your a and your b. Okay, so your x coordinate is going to be 0. And then, Dane, do you remember from yesterday, if I know what my x is, how do I find my y? If not, pass it to Eshe. Yeah, you just what?
Plug the x into
Yeah, you just plug the x into the original equation, right? Okay, so you can decide, you can plug it into this one or you can plug it into the simplified version. Both of them are going to give you the same value. 0 squared is 0. 0 times 9 is 0. Okay, so then my vertex is the point 0, 0. Okay, and then Eshe, after I find my vertex, can you remind us what my next step is? Good. And then what do you put on your table first? Good. So the vertex is going to go in the middle. 0, 0. Okay, and then from 0, I'm going to go up 1, 2. I'm going to go down 1, 2. And then just like we did above, we're going to plug these values in to my original function and see what we get for y. Okay, I do recommend that you use mental math on these. And again, you can use either one. You can use the 9x squared or the 3x squared. I'm going to do 9, 1 squared. 1 squared is 1. 1 times 9 is 9. And then the same thing should happen for this one if you choose symmetric points. Negative 1 squared is 1. 1 times 9 is 9. Okay, 2 squared is 4. 4 times 9 is? Okay, now, when we're graphing this, okay, think about what you want your scale to be. I have to go up to 36. I have to go up to 9. What scale do you guys think would be helpful for our graph? For our y's? Yeah.
5.
Okay, yeah, you could go by 5. Is there another one you guys were thinking? 10s would work? I like 9s. Do you know why do you like 9s? Yeah, they're see how they're both divisible by 9? So I like to if you can do that, that's absolutely what I do. And you can go 5, 10, 15, 20, 25. So that wouldn't get you all the way to 36, but you could go by 10s. So 9, 18, 27, 36. And then my x's, they don't have to be the same scale, so I'm going to have those go by 1s. All right, so I'm going to graph this. All right, so I have 0, 0. Actually, I'll use different color. 0, 0. Negative 1, 9. And then this should be symmetric. And then 2, 36. Okay, this is our g of x. I'm also going to graph the parent function. the parent function is going to look a little different because our scale is different. Okay, so the parent function always stays the same, right? For f of x equals x squared, you have 0, 0. You have 1, 1. So remember, that's a 9, so this is going to be really close to the line here. Okay, at 2, I'm at 4, so almost halfway. And then, like I said, if you're spanning the graph, I would make this something to make that graph easier. Okay. 4 squared is 16, so be really close to your 18. So this is what your f of x would be. And again, the reason why it looks different is because your scale is different. So now you can do the comparison. You can see that this got narrower, right? Your g of x is narrower compared to f of x. Now, when you have stretches and compressions, there are two equivalent answers. So a horizontal stretch and a vertical compression do the same thing, and vice versa. Okay, so we're going to look at this in two different ways. That means, like, if you're doing your homework or a test or a quiz, there are two correct answers for this. Okay? So the first one is, let's look at this, the 3x squared. Notice where the 3 is. It's inside the parentheses. So if there's something happening inside the parentheses, that means it's a horizontal transformation. Okay, now the rule is for a horizontal, it's your f of 1 over b of x. So remember, we are dealing with the what? Reciprocal, okay? So what you're going to ask yourself is, what is the reciprocal of 3? 1/3. Okay, so the first possible answer would be, you could have a horizontal compression by a factor of 1/3. This is your first possible answer. Okay, so if you wrote horizontal compression by a factor of 1/3, yes, that is correct. Okay? All right, but there is an alternative. Don't write both of these. You're just going to write one of on your notes. On your notes, write both of them. Okay? And then if you were answering this as a test question, you would just pick whichever one you want. Okay? So you can decide. So remember how I simplified over here to 9x squared? If we're looking at the 9x squared, let's look at the 9, right? This is outside of parentheses, so this means there's going to be something vertical happening. Okay? If the value is greater than 1, it's going to be a vertical stretch. And this is by a factor of 9. So with vertical, it is what you see. You're not using the reciprocal. Okay? Remember, the rule for vertical is a times f of x. So your factor is a. Your a value is 9. All right, what questions do you have for me on part B? Yes.
So if like a horizontal compression or
Yeah.
a horizontal stretcher and a vertical compression
Yeah.
were like the same thing?
Yes. They have the same effect on the graph. So remember when we did our chart in chapter 1, we had two graphs that both became narrower than the original and two that became wider? The effect that it has on the graph is the same. So when you are doing a horizontal compression, from left to right, you are crunching it. And so that's what makes the graph narrower. But similarly, if you're doing a vertical stretch, you're pulling it vertically, so up and down, and that also makes it narrower. So the effect on the graph is the same.
Okay, so you couldn't use like a times f of x for a horizontal compression.
No, if they tell you like you're doing a vertical stretch, then you would want to apply it. There's a way that you could manipulate the numbers, but you wouldn't want to do that necessarily. Yeah, no, it's a good question. Think about it in terms of the equation. All right, so using part B as a model, I want you to try C. So this is g of x equals 1/2 x, that whole quantity, squared. Okay, so you can use part B to help you. Alright, so if you are, well, you have to simplify first in order to find your B. Okay, in order to find your A, B values from your function, you have to simplify. Okay, so when you simplify, one half x to the power of 2 is like doing 1/2 x times 1/2 x. Okay, or 1/2 squared x squared. When you square a fraction, you do the top and the bottom. So 1 squared is 1, 2 squared is 4, it's 1/4 x squared. Now you can pick out your A and your B value. Notice that, again, there's no x term. That's why we've been getting all these B's are 0. And then your A value is the 1/4 because that's in front of x squared. Okay, so then to find the vertex, you know that it's the opposite of B over 2A, which is just going to result in 0. And then your Y value is going to be, and again, that you can use either equation for. 1/2 times 0 is 0. 0 squared is going to be 0. And then that's going to help you make your table. So you know that your vertex is 0, 0. All right, now we're going to do our table. Make sure that you're making your table. So you have 0, 0. We're going 1, 2, negative 1, negative 2. Anytime you have 0 in the middle, that's what you're going to have. Okay? Again, you can plug 1 into either one. Okay, so if you want to do 1/4 times 1 squared, you're going to get 1/4. 1/4 times 2 squared. 2 squared is 4. What's 4 times a 4? 1. Okay, and then the same thing should happen. Remember, they're symmetric, so negative 2 is going to be 4, so that's going to be 1 as well. Okay, and then again, you can decide what your scale is. I use the traditional scale by ones for this. So I just label a couple of them so we know what my scale is. So I'm going to go negative 2, 1, and then negative 1 I'm going to estimate to 1/4, 0, 0. And this might be another one where I decide, hey, let's see what happens at 3. Right? If I plug in 3, 3 squared is 9. So this is 1/4 times 9. 9 over 4 is 2 1/4. Okay, so that can only help me in terms of the graph, right? So 2 1/4 here, and then it's symmetric. So it's 2 1/4 here. And then you're connecting those with a curve, and then put your arrows on there. And this is your g of x. Okay, let's compare that to our f of x function, okay, which is 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So now we can see that g of x, is that wider or narrower than f of x? Yep, it got wider. Okay, so there's two different ways that could happen, right? For it to get wider, you could be pulling it horizontally, which would be a horizontal stretch, or you could compress it vertically. Okay, so there's two different answers for this. The first one is by looking at the 1/2. What is the factor if you see 1/2 here? What's the factor? The reciprocal. So what's the reciprocal? 2. Okay, so this tells you that it's going to be horizontal, but your factor, your b, okay, this is going to be a horizontal stretch by a factor of 2. Okay, anytime it's horizontal, you're going to use the reciprocal. Because it's 1 over b. So if you have f of 1 over b of x, your b value is 2. Or, but wait, there's more. You could use something else. Can you guys tell me what the other one is? Anybody want to tell me? Okay, by? Good, vertical compression. And look at the pattern, right? If this is horizontal, the other one's vertical. This is a stretch, this is a compression. So it's a vertical compression by a factor of 1/4. And again, that just comes from 1/4 x squared. You have the 1/4 there. Okay, so when you're doing your homework, you only have to tell me one of those. You don't have to do both, okay? All right, questions on part C? Yeah.
How do I find the reciprocal?
The reciprocal is, the definition is whatever you multiply by to get 1. If it's a fraction, you can just flip it. So if it's 1 over 2, if you were to flip that fraction, it would become 2 over 1.
And that's what?
And that reduces to 2. Yep.
Oh, yeah.
Yep. Good. All right, you guys ready for the last example? All right, so example 4, you are using the description that we're going to fill in together to write the quadratic function in vertex form. Okay, so we have to write it in vertex form. You're going to like that. If it was standard form, you'd have to do more work. So vertex form is good. Okay, and then we're going to fill this in. All of these will be directions given to you. Okay? So for part A, it's the parent function, f of x equals x squared. That is vertically stretched by a factor of 4/3. Now, even though it's a fraction, it is a stretch. Can you guys tell me why? What's special about this fraction? Yeah, Julianne? Yeah, it's greater than 1. Okay, so it's vertically stretched by a factor of 4/3, and then it is translated, and I'm going to box in these key terms here. Then it's translated 2 units left and 5 units down to create g. Okay, so that means I'm going to be using g of x equals. So the first thing we're going to do is we're going to just write out what vertex form is. Okay, so this is something that we talked about yesterday, so we might need a quick refresher. So g of x equals a times the quantity x minus h squared plus k. All right, so now we're going to talk about what correlates to different variables in vertex form. So the first thing they tell us is it's vertically stretched by a factor of 4/3. this A value corresponds to the vertical factor. It will also correspond when you have a reflection. Okay, so this is going to be the vertical factor. So in this case, your A value is going to be 4/3. We're going to plug that in. Okay, so we're going to do g of x equals, we're going to do the 4/3 right there. All right, now remember, inside the parentheses, this tells you whether you are going left or right. Okay, your h value is whether you are going left or right. So if we are going left 2 units, that means your h value is -2. Okay, if you're going left, your h value is negative. Now think about what happens when you plug that into the function. Okay, because inside the parentheses, you have x minus -2, which of course is going to simplify to x plus 2, right? So when we write our final answer, we're going to have x plus 2 squared. Okay, and don't forget to put the squared on there. I just wanted to show you the simplification here. And then we have the k at the end. So this tells you whether you're going up or down. In this case, it's going to be down. And then it's 5 units, so your k is -5. So that means you just have -5 on the end. Okay, so I'm going to have you guys try this for part B. Okay, so for part B, you have the parent function, f of x equals x squared. It is reflected across the x-axis. And we don't need 2 ands, so you can cross one of them off. And translated units left and 1 unit up to create your G. Okay, so remember it's the same form here, and then I'm going to let you plug in what you know. So even if you're not sure how to do all of it, there are a couple things that correspond with what we did in the first one. So I want you to try to plug in some of those. Okay, so we're going to start with some things that we know, okay? So Dylan, can you tell me one value that you plugged in based on the description?
For A, I did +1.
Oh yeah, for K, yeah. In my mind I heard A. Okay, so yeah, for the 1 unit up, we know that that's going to be the K value. Okay, so the K value is going to be +1. Good. Okay, and then for +1, okay, and then for the 5 units left, Cooper, what's our value for H if it's 5 units left?
I think plus 5.
Yep, because what was your H value?
My H value was -5.
Yes, good. Okay, so 5 units left is going to be -5, which means I'm going to have x plus 5 inside the parentheses. And then we have that reflection. So remember, when you are doing the reflection across the x-axis, and I saw several of you got this one, the reflection across the x-axis means that the negative is on, is it outside or inside? Outside. So if it's on the outside, it just goes right here. And I know some of you put -1, that's fine, you just don't need the -1 there. I wouldn't mark it wrong if you had it. You just don't need it. That would be the simplest form. All right, so I'm actually going to go over some homework stuff with you. And show you where to find that on the calendar.